The purpose of this video is to illustrate the attribute crosstab approach to measurement systems analysis within the QC Pro Gage management software. This is sometimes called go-no-go type of analysis, and we'll be using the automotive industry action groups within that reference manual, the numerical example that's shown there. So to begin with, we'll go into the transaction segment of the software. We've already got a gauge set up here. Happens to be a plug gauge. And we're going to do a new transaction. There's already one transaction in here that occurred related to a calibration, but we're going to do a new transaction by clicking on the new button. And let's say that particular transaction occurred on February 13th, 2018, and the person that sort of overlooked the entire study was Frank. We're going to be doing not a calibration but a measurement systems analysis, so that's MSA. And specifically from this little drop down list of MSA type of studies, we're going to choose the attribute crosstab analysis. And when you do that, you can have up to 3 appraisers, up to 50 parts, and up to 3 trials. And we're going to leave it at that because that's how the example in the AIAG reference book is presented. So once we've done that, we can go into the data entry segment of the software. Here we have 3 appraisers, which are color-coded in blue, green, and red, corresponding to, in this case, 3 columns or 3 trials per appraiser. So for example, appraiser A, the blue color, has 3 columns representing 3 trials. So too with appraiser B and appraiser C. And we can assign names to these appraisers. For example, let's say appraiser A is John, and appraiser 2 is Jane, and appraiser 3 is Ben. Now we've actually in the data entry grid here, we've pre-populated the grid with 1s. 1s represent a go type of situation. 0s would be no-go. And we would adjust these accordingly. So for example, in the AIAG reference book, for the very first row in their numerical example, all appraisers on all trials say that this particular part is a go. So that's represented by 1s, and we'll just leave it alone at all 1s. And then this column called reference relates to the truth. Is it a go or no go? Well, in fact, it is a go. The part is actually a go. And if you want, you can also enter what's called a reference value, which represents the true measured value if you were to measure the dimension. And then over here, we have a code system, which is actually going to get filled in automatically once we go into the analysis portion of the software. So if we look at the first row in the AIG reference book, again, that's all 1s for the appraisers and trials, and the references is also 1. In the second row, it's also all 1s in the AIG reference numerical example, and the truth is it really is a go. In the third row, however, it turns out that this is a no-go for all appraisers and all trials. So we'll kind of just enter the numerical value of 0 to represent no-go. And the truth is, or the reference is, that it really is not a go. So it's a bad part. And so for the remaining 47 rows, rather than sitting and wasting your time by entering all that stuff, we'll stop at this point and we'll pre-populate it with the correct values, and we'll come back in a moment. So now we've populated the data entry grid with the same values that we would find in the AIG reference book, and you'll notice that now row 3, 4, and 5 are all no-goes. Now, row number 6 happens to have a mixture of goes and no-goes. So, for example, for Appraiser A, Trial 1, they're saying it's a go. For Appraiser A, Trial 2, they're saying it's a go. And for Appraiser A, Trial 3, they're saying it's a no-go. So this is where things get interesting, where you have sort of a discrepancy between multiple trials for the same appraiser and also between appraisers. And so for this particular example, for the 6th row, it really is a good part, but we're sort of at the gray area or marginal area of where things are hard to determine whether it's a good part or a bad part. And that's kind of an interesting situation. So the remaining rows have now been populated with zeros and ones according to the AIG reference book example. And so the next step will be to have a look at the analysis of this data set. So to do that, we click on OK. That takes us back to the previous screen, the transaction details screen. And we'll click on the Apply button, and then we'll look at the analysis. So for the analysis, we see several cross-tabulations, which we're not going to actually talk about from a technical point of view at this point. You can refer to the AIG reference book for that. But just quickly, for example, Appraiser A versus Appraiser B cross-tabulation, we have the situation where the product or the part that's being looked at is a no-go. This column has a 0, no-go, and this row for Appraiser A is a no-go. So Appraiser A, no-go, Appraiser B, no-go. That happened 44 times. In other words, they agreed 44 times that this particular part is a no-go. If you went through that matrix of zeros and ones and you counted up all the zeros where A and B, Appraiser A and Appraiser B say it's a no-go, that happened 44 times. And in a similar way, where Appraiser A said it's a good part and Appraiser A said it's a good part, that happened in this case 97 times. So these are the two cells that we're kind of interested in generally, and you know, we end up with these cross tabulations, which are then used between Appraiser A and Appraiser B, between Appraiser B and Appraiser C, and between Appraiser A and Appraiser C. You have these various cross tabulations, and one can then calculate the statistic that we're going to be using in this analysis, which is called a kappa value. Kappa value is basically a number between 0 and 1. 1 meaning that the appraisers agree totally, 0 meaning they don't agree at all, and then some number in between, meaning that sometimes they agree, sometimes they don't agree. What we're looking for is a kappa value that's 0.75 or higher between appraisers. So for example, for Appraiser A and Appraiser B, we're getting a kappa value of 0.86, which is pretty good. It's more than 0.75. So we can say that generally Appraiser A and Appraiser B tend to agree in the majority of cases. And the same idea for Appraiser A and Appraiser C. We're getting a kappa value of 0.78. And finally, Appraiser B and Appraiser C, we're getting a kappa value of 0.79. So in general, because all these kappa values are greater than 0.75, we can say that the appraisers are doing a pretty decent job agreeing with each other. And so the guideline that we have here in the report is appraiser by appraiser agreement is good. Then the other thing that might be of interest, so this is between one appraiser and another appraiser. The other thing that's of interest is how well are we doing against the truth? How well is Appraiser A doing against the reference cross tabulation value? Against the reference. So, you know, if Appraiser A said it's a good part and it's actually a good part, that's great. If Appraiser A said it's a good part and it's a bad part, that's not so good. So if we look at now instead of appraiser up here, we have the actual truth or the reference of no-go and go. In the case where Appraiser A said it's a no-go and it truly is a no-go, that happened in this case 45 times. And it's in the case where the part is a good part and appraiser A is saying that it's a good part. That happened 97 times. So again, we have for appraiser A and appraiser B and appraiser C these cross tabulations against the truth, and we can calculate a kappa value, and again, a number greater than 0.75 means that we're doing pretty good. So in this case, appraiser A against the truth is 0.88, appraiser B against the truth is 0.92, and appraiser C against the truth is 0.77. So all of these are more than 0.75, so we can generally say that there's a fairly good call, that is to say that each appraiser is calling it in a fairly good way against the truth. And finally, and so the guideline here is appraiser by reference agreement is good. And then finally, we have a little sort of grid which reflects on how effective and against the truth each appraiser is. So 84% of the time appraiser A is doing a pretty decent job. Appraiser B is effective 90%, like whether it's good or a bad part. And appraiser C is effective 80% of the time. So, you know, these are pretty decent numbers against the truth. Then we have a column here called a miss rate. In other words, let's say the part is a bad part, but they're calling it a good part. So for appraiser A, that's happening roughly 6.3% of the time. Appraiser B, also 6.3% of the time. And appraiser C, 12.5% of the time. And then false alarms would be where we have a good part, but we're calling it a bad part. So appraiser A is calling that roughly 4.9% of the time. They're saying it's a bad part when in fact it's a good part, and so on for the remaining appraisers. So that's pretty much it for the cross-tabulation approach to measurement systems analysis, and thank you for watching this video.